So just now, by looking at the animation, you might have very well understood that when a plane progressive wave, which is transverse in nature and moving along positive x direction, when it passes through a particle of the medium, which is, say, for example, at the origin of the coordinate system. So when this plane progressive wave passes through the particle, this particle oscillates along y direction once. So when one wave passes through the particle, this particle travels up and down and completes one oscillation. So at time is equal to 0, the wave was here. After the wave has completely passed from this particle has completed one of its oscillation. So in time capital T, two things has happened. One, this particle has completed its one oscillation and the wave has traveled some distance. Now let me tell you, the distance traveled by the wave is measured from front part of the wave. So this is the crest and this is the trough. So from front part of the wave to the front part of the wave, or you may take bottom part of the wave to this bottom part of the wave. So this wave is now going to be here, and that is what I have shown you here. So the distance traveled by the wave from back point to the back point is equal to the wavelength of the wave, that is lambda, right? So if I say that the distance traveled by the wave, distance, that is equal to speed multiplied by time, right? This distance is d, speed of the wave is represented by v, and time is t. So the distance traveled by the wave in capital T time, so I'm going to substitute capital T time over here. This is the time taken by this particle to complete one oscillation, and in the same time this wave has traveled a distance equal to lambda. So I should say that the distance traveled by this particular wave is equal to lambda times, that is equal to speed times the time period of this particle, or time period of the wave also you may call it. So let me take this at the denominator of this particular equation, v. Now 1 upon time period is the frequency. So lambda times f is equal to v. So this is the equation. By the way, this is the frequency of the particle, that means this particle which is oscillating due to the influence of this passage of wave through it. Now imagine if 10 waves pass through this particular particle, this particle will go up and down 10 times, or it will complete its oscillation 10 times, right? And the distance traveled by the wave would be equal to 10 lambda, right? So in that way you can derive this expression. By the way, this is known as wave equation. So this equation, which is the wave equation, even though it is derived by considering the transverse wave over here, but you can still apply this for the longitudinal waves also. Now one more important fact over here to be noted is, suppose the amplitude of the wave is a. Then this particle will also be lifted up by the same distance a, because the top point of the crest will take this point or this particle to the same distance equal to that of the amplitude. So from here, the important points to be noted are the following. Number one, frequency or time period of particle which is oscillating is same as that of the wave. Number two, the amplitude of the wave is same as amplitude of the particle. And this does not apply for a single particle. As many as particles, suppose there are n number of particles which are on x-axis, all of them, they will oscillate with the same amplitude a, and all of them will oscillate with the same time period t of this particular particle.